Okay, everyone, now finally to question 10. After we finish this question here, that means I have done 10% of the 100 integrals, all right? So very, very exciting. I want to show how to do this question here. All right, so how do we do this question? We have x to the power 3 divided by x squared plus 1. If we try to use the logarithm integration, try to differentiate the denominator, it's not going to work because it's not equal to 2x. I have x to the power 3. You have a higher power on the numerator than the denominator. So the way to do it is you can either use long division to separate this fraction into 2, or you can use the algebra to separate the fraction into 2. So I'm just going to use the algebra to do that. So I am going to add x, and then I'm just going to minus x straight away. The reason for that is because I can create two fractions. And the first one is with these two groups together. And that's how we created two fractions. So once we finish that, then we can factorize the numerator. And that gives us, if we just take x outside and factorize the numerator, that gives us x squared plus 1. Now hopefully you realize that I can cancel these two terms because they are exactly the same. So you have x minus x over x squared plus 1. So as you can see here, we've got two terms, all right, coming from one fraction. So after we finish this one here, then we can start to integrate. So let me just rewrite the question here. All right, so how do I integrate x? Integrate x is equal to half x squared minus. How do I integrate the second term? Now I want you to think about it, right? This is a fraction, so if we differentiate the denominator, that becomes 2x. So I need a 2. So imagine that you need a 2. You need a half outside to balance the 2. So I need a half outside to balance the 2. And then logarithm absolute value plus 1 plus c. So that's how you do this question here. So this is question 10. Very interesting. You can either use the long division method to create two terms, or you can use an algebra method to create two terms. So you have a smaller power on the top comparing to the denominator. Then you can apply the logarithm method to solve this question. All right, thank you everyone.